But one says, look, there was an independent being prior to it all that spoke it into existence. And Krauss is obviously not a fan of that. He said, no. Howdy, folks. Welcome to the channel. I'm Don. I'm looking at a scientist destroys atheism in 10 minutes. These titles always crack me up, regardless of who's doing the talking and what they're trying to prove or disprove, that so-and-so destroyed so-and-so. That never happens, okay? Neither side walks away. Atheists don't walk away from the debate because usually a Christian theologian destroys their position. Christians don't walk away because scientists or an atheist destroys their position. It always cracks me up when they title these things this way. But let's find out what this one is about, because I like looking at the arguments. I like hearing what folks have to say. It doesn't matter to me whether I agree or disagree. There's always some morsel of something that I pick up from somebody's position that I didn't know previously. And one of the things I learned as a philosophy major several decades ago when I was at Rutgers is to entertain strains of thought that you might find uncomfortable or disagree with, because you find out that there are some really good positions out there that you never would have considered. You know, when you study things like what makes something right, and then you'll hear, oh, so-and-so Thrasymachus says that might makes something right. Strength, power makes something right. You're like, that is just morally wrong, ethically wrong. And then you hear the argument laid out and you're like, oh, well, it is kind of the way it works. The strong ones make the laws. True in the jungle, true among mankind. We just do it in a more drawn out civil way, generally speaking. Let's see what this scientist has to say about destroying atheism.
And they were very excited that I agreed to do this, because if you appear on stage with someone talking about these things, it gives the impression that the ideas are worth debating, or that the person is worth debating. In this case, neither is true. I'm going to continue to disparage Stephen for a little bit.
This was a debate between an atheist scientist, Lawrence Krauss, and a Christian who's a scientist, Stephen Meyer. As you can see, it started with a bang. I'll keep most of my comments toward the back end, but I want you to see the evidence that Meyer presents, and then we'll get right to that back and forth between Krauss and Meyer and how the...
Oh, Stephen Meyer, I guess he founded the, was it a museum for creation? All right, so Stephen Meyer. All right, here we go.
Christian responds, I think it collapses the atheist case like a house of cards. But let's jump into the setup first, right now.
Professor,
now, there are lots of things that do give this appearance of design in biology. The discernible architecture of an animal body plan, the intricate organs such as eyes and hearts and things that we find in the world of mammals, the intricate circuitry, genetic circuitry that we are now discovering that controls animal body plan development. And yes, these amazing miniature machines that are being found in cells, including the now famed bacterial flagellar motor with its many protein parts, rotor, stator, bushings, drive shaft, etc. But from a biological standpoint, whether you accept Dawkins's explanation or not of apparent design, all biologists recognize there's something that lies biologically underneath all these appearances of design. And it is the information necessary to build these exquisite structures. And we now know about where a lot of that information is stored. A lot of it is in DNA. We're finding that it's also stored in other places in living organisms. Now, just looking at that intricate motor from a minute ago, and then look forward to, this is one of the parts of that motor. The motor is made of proteins. The proteins are made of subunits called amino acids. And to get the parts of the motor to fold into the right structure, three-dimensional structure, the amino acids of each protein have to be sequenced properly. And that's where DNA comes in. DNA provides the instructions for arranging the amino acids that cause the proteins to fold into three-dimensional shape, that allow proteins to do all the amazing jobs they do in cells. They catalyze reactions, they process information, they build the structural parts of intricate machines.
I think I did a video on this a while back on the necessary proteins within each cell and the number of proteins, but the way in which they have to fold over. It's not enough just to have a collection of amino acids within a cell and they do the work. They do have to be sequenced in just the right way in order for them to fold over and become like this three-dimensional object that forms the cell. But they can't just be this random collection. They do have to be sequenced. And I think there are anywhere from 150 to, I've seen numbers as high as 20,000, but I think the number is somewhere around 250 amino acids that comprise a cell, a standard cell in the human body. And they do need to be sequenced just so, or the cell itself doesn't work.
Now, our appreciation of what DNA does, of course, started with the discovery of its structure in 1953 with Francis Crick and James Watson. And even more, and this was the famed double helix structure that we all learn in biology. But I think even more significantly was the recognition by Francis Crick in 1957 of the digital character of the information that's stored in the DNA molecule. This is his famed sequence hypothesis. Crick argued that the four characters, or the four chemical subunits that run along the interior of the molecule, called nucleotides or nucleotide bases, function just like alphabetic characters in a written text, or we might now compare them to digital characters in a section of machine code or software. The information stored in DNA is a striking appearance of design. Dawkins himself calls the machine code of the genes uncannily computer-like and compares it to what you might find in a computer engineering journal. He goes on to say in a more recent interview that genetics has become a branch of information technology. It's pure information, it's digital information, it's precisely the kind of information that can be translated digit for digit, byte for byte. He goes on to say that Darwin would have been fascinated by the discovery of the information at the foundation of life, and maybe he would have been. But it also turns out that evolutionary theory has been unable to explain the origin of this information.
Ooh, it's always about origins. I bring this back a lot. With our pattern recognition as human beings, we look for origins. So the notion of whether God exists or where did the matter in the universe come from? Which preceded which? Because we are temporally oriented. We are oriented toward time, and partially because we are oriented toward pattern recognition, which requires beginnings. This is what we look for. Where did that thing come from, whatever that thing may be? We see a bridge, for example, and we know it had a designer, right? So our minds are wired toward when we see stuff saying, where did it come from? Who made that? Who put it there? How did it get there? If anybody put it there at all? Or did the wind just blow that tumbleweed into that, on the front porch of someone's house or wherever it was? Like, what? How did it get there? And so when we say that all the matter in the universe came from somewhere, that is actually a rational or logical position. Doesn't mean it's right. But then the counter to that is saying, well, if God or a creator made all this stuff, where did that God or creator come from? While we're at this bit of origins or beginnings, where did that being get its start, get his or her start? And you're like, well, that is equally valid. But I like that he's going after the idea of origins and the way we continue our learning and what we discover. These debates are a lot of fun to watch, to see unfold, because as more of a philosopher and looking at epistemological limitations, what we can know and can't know, these may be continuing to lead down in a sort of fractalization, if you will, where we keep getting into smaller and smaller and smaller bits of information, but it doesn't mean that those won't continue to get smaller and smaller as we become more acutely, our ability to discern the small grows. Maybe what we're observing now will become the equivalent exponentially of how we view the size of the universe. Maybe a single cell will appear to us at some point, based on our ability to detect things, to be basically the equivalent of the size of the universe, because there's so many subatomic particles and elements that we discover. Many worlds in there. We just don't know.
This is because it's been the information at the foundation of life has turned out to be a difficult thing to explain for two different branches of evolutionary theory. Chemical evolutionary theory, which attempts to explain the origin of the first life and the information required to build it from simpler non-living chemicals. And biological evolutionary theory, the origin of new forms, which attempts to explain the origin of new forms of life from simpler pre-existing forms of life.
Yeah.
In both cases, by reference to the principle I just outlined, you need new information to build new biological form, whether we're talking at the one cell level or at the multicellular level of a new body plan. In Murray Eden's words, that no currently existing formal language can tolerate random changes in the symbol sequences which express its sentences. Meaning is almost invariably destroyed. Now, there's a reason for that. If you got a combination lock with 4 dials on it, and each dial has 10 digits, how many different possibilities are there? Because we're all tempted to say 40, 10 plus 10 plus 10 plus 10. But of course, that's the wrong answer. It's actually 10 times 10 times 10 times 10. That's 10 to the 4th. So that's 10,000 possibilities. And that's why the lock works. There's a lot more ways to go wrong than right. So if you want to search for the correct combination that's going to open the lock, perform a function if you're a thief, you are overwhelmingly more likely to fail than to succeed. A random search is more likely to fail than to succeed. Let's say there's a thief outside the auditorium. He sees a bike. He wants to figure out how he wants to crack the code, crack the combination. If he's especially diligent, he turns one dial every 10 seconds. In a little over 14 hours, he can get to 5,001 combinations, which means at that point it would be more likely that he would succeed than he would fail. In which case, the hypothesis of a successful random search might be more likely to be true than false. But what if our thief faced a lock like this? With 10 dials, not 4 dials. Now how many possibilities are there that need to be
10
searched?
to the 10th.
Well, now the number increases dramatically, exponentially. It's 10 to the 10th, or 10 billion possibilities. I did the same math. Turns out that in 100 years, if he does nothing but search those dials, he's going to search no more than 3% of that entire, all those possibilities in his entire life. Right. So now ask yourself a question. Is it more likely that the thief will succeed or fail in a random search of the total number of possibilities? Obviously, it's more likely that he'll fail. He can't sample enough of the total space to have a reasonable chance of succeeding. It's going to be overwhelmingly more likely that he'll fail than he'll succeed. In which case, the hypothesis that he would succeed is going to be more likely to be false than true. Now,
all right, but here's what I will insert here as a simple matter of logic, data distribution, and so on, that in probability theory, there's a difference in probabilistic approach before an event happens and your analysis of after it happens. If I play the lottery today, a standard lottery, Mega Millions or whatever, I think the odds are 1 in 292 million that I'll get the right numbers. So you say, what's the probability that I'm going to win it or that you're going to win it? And it's 1 in 292 million. Very small. When you say, what's the likelihood that somebody's going to win it? You've got people all over the country playing the game. It goes up much, much higher. Now, let's say I'm holding the winning ticket. You say, well, what was the probability that I would win the lottery? After the event, the probability is 1. 1 means it happened, right? Probability is measured on a scale from basically 0 to 1. 1 means absolute certainty it's going to happen that way, or it did happen that way. So what's going on here, and I like that it's going into the scientific stuff. I love knowing this stuff. After something happened, if you're applying a probabilistic model that rightly applies to before an event happening, you've got a gap in your logic, in your reasoning. That's the problem. What he may be doing is merely with the DNA and the information and the chemical and all these questions about evolution And they are legitimate questions and issues about evolution. How do a bunch of lifeless things come together in the primordial soup and all of a sudden you've got a living organism? And then how did that one organism reproduce itself in order to make other ones that could then, through natural selection, morph and defend themselves against harsh environments and all that harsh environment, and then grow to where we come? Humanity is here. Some philosophers of science or atheists would simply say, look, we're just observing the means through which it happened. There are maybe gaps in our understanding, certainly there are, but we're going to get there. But what he's doing here, and this isn't a criticism of him, it's a common mistake people make, is to say, what was the likelihood of that happening? And it's like, well, before the event would be very tiny. After the event happened, if that event already happened, it was highly likely to have happened. In fact, 1.0.
This all applies to life because DNA and proteins are also combinatorial systems. They can be likened to bike locks. There's lots of possible ways of arranging those ACs and G's and T's along the spine of that DNA molecule.
Okay, right now we're going to hear how the atheist scientist reacts to this, and that is going to be great. But there seems to be this digital information in DNA, and it doesn't seem like there's been enough time to produce anything beneficial out of that. Meyer says it needs specified complexity. If you and I were playing a card game, any arrangement of cards I dealt you would be ridiculously unlikely. But it's not just that it's unlikely. It's like having the specified complexity of having exactly the hand that you need to win the whole game and having it over and over and over and over again. That's what Stephen says is going on with DNA. It's not just that it's incredibly unlikely. It's that it's the specified complexity that makes it work. That's what indicates intelligent design. Now let's jump in and hear how Krauss responds.
Evolution is not a random process. I mean, and Richard talks about it and at length, and so should we all. Evolution is a directed process. It's directed by natural selection. It's the argument you gave is the same as the argument that the old argument, well, it's, creating a living being by evolution is like a hurricane going through a junkyard and producing a 747. That sounds pretty convincing if you talk about all the possibilities for all the parts in the junkyard, but that's not how it works. It's directed. Digital algorithms, which you tried to talk about, is the machine that just want to go. Okay, it used evolutionary learning algorithms. It could have, if you looked at all the algorithms it could do by random, in the history of the universe, it would never be able to win at Go. It wasn't directed or the algorithms weren't even written by the computer scientists. The machine itself learned by trying different things and seeing what worked and didn't work, and threw out those directions that didn't work. In a short time, in fact, the lifetime of deep thought, that machine, which has only been around for a few years, it was able to beat the best Go player in the world by evolutionary algorithms.
There's a big difference between a purely chance hypothesis and a hypothesis that combines chance and natural selection. And the critique that I'm providing is one which is critiquing natural selection acting on random mutational variations. So I'm not arguing from chance alone. The point is that so I'm perfectly aware that the mechanism that I'm critiquing is not straight chance, but it's a search for possibilities, and then natural selection would select those that are functionally advantageous.
I think what's missing here from the debate, now where Krauss missed it here, I think is opportunity in the debate as a matter of argumentation, where there's a thing called negative evidence or absent evidence. It's the planes that never crash. You don't hear about, you don't think about. The ones that you hear about, the sensationalized ones, are every so often a plane crashes. It's rare, but that gets splashed all over the media, so it's kind of in your mind that those are the relevant events with flying. Now, in a similar way, with Krauss's hurricane example, or counterexample, with going through the junkyard and creating a car or whatever it was that the hurricane would create by chance. If there had been a trillion or a billion or whatever number was hurricanes that went through junkyards and created messes and messes and messes, but partially came created a car, maybe made a bicycle over here, possibly a log cabin over there, or what have you, then you say, all right, yeah, you're right. But the reason we're able to even analyze the information within the cells, or the reason we're even able to admire that car that got produced, is because there were so many attempts at it. There were so many events. We didn't hear about the ones that didn't make a car because those just weren't, they were irrelevant. It was just scattered junk around. The one that got our attention was the one that was made. And that's an argument that some philosophers even make about mankind, is that the only reason we can even study this stuff is because that event did happen. We are here. We are looking at an after the fact analysis. That's what this debate is about here. Krauss is convinced that we're looking at an after the fact analysis. This is the way it happened. And Stephen Meyer here is saying it had to have been directed by an intelligent designer, a living independent agent. And Krauss is saying, no, it's just basically inanimate natural selection that sort of learns from its own way of being. It sounds remarkably anthropomorphic or anthropological beyond personification, where you're saying that this artificial intelligence, if you will, it has its own mind. It's directing something. That language bespeaks autonomy. So the language that they're both using, whether they like it or not, is remarkably similar in how they're depicting the way in which mankind came to be. But one says, look, there was an independent being prior to it all that spoke it into existence. And Krauss is obviously not a fan of that. He said, no, that being is just some random thing.
And so I don't have a simplistic understanding. And in fact, in my work on origin of life, I look at chance hypotheses, those that combine chance and necessity, including the RNA world hypothesis, and also those models that involve self-organization, and that really is comprehensive as far as the different models that have been proposed. The algorithms that Professor Krauss mentioned are very interesting simulations, but they invariably involve information being input by the programmer. Dawkins has this famous algorithm where he says he has the program simulate a Shakespeare phrase, methinks it's like a weasel. But it doesn't simulate the way things actually work in biology, where in biology, in the algorithm, he's positing a process. Anyway, the programmer inputs information in the algorithm.
So in the end, if a programmer has to give the kind of information that Meyer is talking about, that's intelligent design. The programmer is the intelligent designer. Far from showing that there is no intelligent designer, this seems to support the intelligent design case that to get information like this in the time we're talking about, you need an intelligent designer. Now, there's far more to say about this, and it's not just intelligent design that gives evidence that there's a God. There's also evidence from the beginning of the universe.
Yeah, these debates are absolutely scintillating. I love it. If I were to have to pick who won this debate based on what I saw here, I would say Myers did. But of course, it was focused more on him. And the gentleman here who put this together is himself a professor of theology, a seminarian. And so naturally, he's going to side with the intelligent design. But it's fascinating to see just how similar the language is being used. But one wants to say there was this independent agent who input the sequencing, the information. And I love that perspective, though, that this is about information, the coding that's in there that's discovered in the DNA and the RNA. DNA, the deoxyribonucleic acids, RNA, ribonucleic acids, all this stuff, and how the cells organize themselves. They need some kind of information, and that information shows the cells basically what they are and how they're going to function. And Krauss and the atheistic perspective is that no, that is just inanimate, basically. It animates things. the data over. Now, here's the thing. We're looking at time. And the argument from the atheistic side is that over large expanses of time, these things would naturally occur. And it's tough to speak against that perspective too, because it's one of those things that we cannot really test. I mean, I guess now with artificial intelligence, we can test various things. We test things in laboratories all the time with bacteria, just to see what sort of combinations work and what don't work. The ones that don't work, we never hear about. The ones that do turn into medications that may help us and may not, for instance. But the sequencing, even of those chemical processes for medications, is significant. And in that case, requires a designer. But it's still one of these things that we cannot test. I mean, if you're a Sir Karl Popperian or Popperite, you would say, well, we can't duplicate this in the laboratory. Not now, and certainly the Big Bang and all these, the expansiveness of time. Right now, we're positing that the universe is 14.5 billion years old. That number may be off by magnitudes, making the universe trillions of years old. I don't know what we're going to discover, but one thing that we should know is that we don't know it all. Things change. We acquire new information that we need to account for, plug it into our current hypotheses, or they overthrow current hypotheses or theories. Einstein might have been wrong about the speed of light. And for example, right now we're finding James Webb Space Telescope, my hat, is finding that there are galaxies traveling away from us. They're redshifting faster than the speed of light. That is not supposed to be able to happen. So if it does, is it possible that the universe itself maybe has just always been here? And we're just observing our one trillionth part of that monstrosity. But I love the perspective of the information required within cells and living organisms in order to reproduce, whether it's an acorn falling on the ground that grows into an oak tree, or a fish laying an egg, or whatever it is. The information needs to be in those cells to tell the future cells as they grow even within the womb of a woman and human beings or wherever, how to grow. So, all right, guys, hope you enjoyed that. This is fun. This is absolutely fun. And I'm fine with questions. I don't have to have answers. But answers are pretty cool once in a while, too. All right, have a great day. Please subscribe. See you on another video. And keep thinking philosophically.